Hello, welcome to my MyWebUniversity free educational videos. Today I'm going to show you more of Python tips and tricks. So without further ado, let's get into sharing the screen first. Let me share my screen first. Basically, you will be seeing right now at the website on my YouTube channel, MyWebUniversity free educational videos. And last time we showed you Python tips and tricks with command line, which was from this video that is here. And this is already posted, so it's about 17 minutes, and you're welcome to watch. And I'm showing you how to do command line from Python, using Python from operating system, how you use the command line to just run Python one-line script. And without the details of that script, let's just get into tonight's session. So for tonight, I prepared this slideshow that I'm going to do right now. Open up the first one, which we already talked about, is the Python tips and tricks. And I just labeled it number 1 for the Python command line tricks, which was that video that I just showed you, that is 17 minutes. So the second video that I'm going to do tonight is going to be posted after when it is done tonight. And this is Python tips and tricks with showing you the import keyword. Python has an import keyword that you can use to import modules. So when you're importing modules, basically you're able to do activities within any modules that are there, whether the module has some class, some functions, some methods, some properties, constants. You can use them inside your Python scripts. And as you know, Python is both a functional programming as well as object-oriented programming. So a lot of the classes that are written on those Python, and then the methods that are there that are just you load it, you can use them as you wish by just importing those modules. So let's just go through the description of what we're going to talk about today. And I'm going to just close the presentation, the PowerPoint presentation. We don't need it anymore. So, and then minimize this window, and I'm going to go to Pycharm. So in order to do the two modules that I was talking about, importing modules, I wrote a couple of modules. So one was to just use the import keyword, and then another one is to just actually do some application of these modules with plotting some graph of sine and cosine functions. And then also just at the end of this import, before the plot menu, maybe I could just show you inside this import modules how to do like a lot of numbers, just generating random numbers, 6-digit numbers for the lotto. So I could show you that one using Python. And then let me put this one on the side here because I don't want to be blocking. So as you can see, the interface that I'm having right now is Pycharm. And then on the right side is actually here is everything that is the modules or the code of Pycharm that you could write here. It's not much here on this example, but as we grow on the tips and tricks on each of these ones, I will go more in details when it comes time to go more details. At this time, I need to just be specific to show you how to use the import module. So let's just go on the first example here. When you use the import module, you're basically loading a module. So the import is the keyword, and then the math is, in this case, is the name of the module. So on this line number 10, I'm saying import math. And math is a module that is a standard library of Python that is supported. It is not, it's coming by default when you have Python 3.10 or whatever version is installed. Math modules is part of the standard libraries. It is, you don't have to use a pip install to do it. But there are other modules later on I'm going to show you that you have to install them in order to do it, like numpy or regular expression. Regular expression is part of the standard, like plot menus and other ones, like let's see, request modules if it is not there, matplotlib and other ones. So you just load them as it is not there. But if it's part of the standard, you don't do it. In order to know what are the modules that are there, you just go on the Python and just go help, and then get the list of modules available on your system. So let me just show you specifically what I'm talking about. Here, like if I just clear my screen here, and I just say Python 3, and just to know what are the modules here and that are already there, I could do this, help and get the help, and then type in modules here. So all the list of modules that are inside Python, it will be available here. And if you don't have it, you just do a pip list, it will list it. And if it is not there, you just pip install. That's how easy it is to do it. Pip show would also show the module name. But for this one, I'm going to show you the import modules. So while this one is just loading, which should be loading right now, I need a second now. Let's just give it a few seconds because it's the list is huge. That's why it is taking a little bit longer than normal. And I'm going to just go back here. It might just be already returning values, or it is still waiting. So let's just wait for a little bit. So at this time, I say import math. What we are doing here is importing the modules as math. And then whenever you want to use this one, you could say dir of math to see all the modules, and you could do like math dot some functions, and then use the method for it, or math.pow for using the pi value, constant value of it. But the object of import is that the keyword you use is to install, to load the module for usage in the scope of that environment that you're doing it. So then you could also do from math import star. This is not recommended. This is very kind of tedious or a wrong way to do from math import the star. When you say import math, that is already those functions are available. But if you do use like pi function, then you're going to do something like, let's say math.pi. That would give you the pi value, or math.cosine, or math. Whatever a power function, or a square root function, or floor, or ceiling, or anything, you just use those methods there. But at this time, you're seeing these import modules that is specific to each one of them and with different syntax. I'm going to show you the advantage and disadvantage of those syntax. So if you write from math import the star, this is not recommended, because the star is just putting everything available. Now you're just using, for example, a square root, and then you don't know which modules were there and that were there. For example, the power function would be kind of confused, because the power function has, it comes with a standard library of Python. It also comes with math modules. And there are two different syntax for each one of them. And I'm just going to show you the difference between those two, that why this is not recommended. And I put it as a pound here. When I just uncomment it, I will tell you why. So the import math as M, this one is a short name as an alias, and that you're pointing to whatever the math is modules doing it. Now this copy of it or alias, M is also doing it. So M is also a class of math module type. And then you could do m.py to get the same thing. But when you want to just do the square root, you could just say from math import square root. This is the first one that I was, the third one that I was explaining, import math as M. The name M is too short. Sometimes it's hard for other people to understand what did you mean at the time when they're reading thousands of lines of code, and then they have to go back, say, what do you import M as? And then now you're using the M class or M object or M module as this reference it somewhere in the maybe 400 lines or 500 lines, 1500 lines or something there, and then it's getting confused there. When you do from math import square root, this is a little bit better than the M, but square root also is that if you do the same thing like from math import POW for power function, then it's going to get confused because the same library is provided on two environments. Then it is not going to understand you are using that one unless you go specifically say math.pow of this, or just not do the import star. So this one is from math import ceiling to get the ceiling function, and then you could do similarly from math import floor. You can just load the floor functions. And then when you do from math import floor as FL, this is very short name. I wouldn't recommend this one either. So this is let's just comment that one out as well, and then not use it. And this also random integer, it should not be like this short. From random import random int as RI. Don't be just lazy. Basically, if you're kind of making it easy for just remembering the name short, yeah, there are times that everybody just standardize it, or like from numpy import, numpy as, you could just write like import numpy as np. And then you do that one, and most of the programmer knows that they're using it, that short name. So you're not using numpy dot whatever array of a function or something. And then for similar for pandas, and if what you make a short name, it has to be making sense to more programmers and developers around the world. That way, and when they read your code, they are not confused with it. So right here, I put some kind of rules saying when importing modules, keep the name short, but not too short to confuse others. And then keep it simple, silly. And then some people say silly, some people say stupid. I would say silly. Keep it simple and silly, and don't be lazy on the naming convention. And just don't make it like too short that only you understand at that moment, but maybe 6 months down the road you have to reread your code. That's not good coding there. So these are the way that you import these modules. So let's just uncomment all of them and then just see. So when you just import a module, if you don't use it, sometimes Pycharm kind of like let you know that, well, you did not use that one, why you're just defining it. And so unnecessary loading modules on the system is not good. But if the system does not inform you, you should never just leave these modules loading it, because at the time at runtime, your code is going to be much longer and time consuming. When it is supposed to go 2 seconds, it takes 3 seconds. So that's not good. And then so here, if you say import math, and then here I also did import math, that's duplicate. Don't do duplicate stuff. When you do something on top, try to be specific, like when you start from the main module, write that one on the top, and then when you write the second one and there as something, you gave it that one. Be a little bit consistent with your coding. Right now, I'm just telling you something which I'm not following myself, but I will follow it because this one needs to go up on the top, and then I should have deleted the other one. So this is like, if you do this, import this or this, whatever you want to do, make sure that you're consistent with the naming convention and then the order that you do. This is just for demo. I'm importing a lot more than I should be doing it, but I'm trying to just tell you how to import something from modules. Notice that the first one, or a lot of them, are from, and then the most of the time you just say import numpy as np, import math as m, or import math, or import from math import ceiling, or from math import square root, that kind of things. So now notice that if you do the square root of 100, and if this is not commented out, even though when I do import math, automatically square root is available for me. So that code is available for me. But I'm going to show you a little bit more on that information for, you can see the square root is right now is commented out, and I'm going to leave it comment out. And just for now, I'm going to comment these lines. Comment these lines. When you do the three string, and then you just put all of the string here, that's like Python way of saying comment these lines. So I'm not going to comment all of these lines here. I'm going to just move this one to right in front of these two. And then this one is going to be commented. Pycharm try to help you. Sometimes it is not as smart enough to just know that you meant 3 characters on the top and you're moving that one. But sometimes you could just put the 6 character and press enter, and then move, cut and paste the content of your data, so you can help Python back because it's trying to be helpful, and it is very helpful in most of the cases. Pycharm is very good IDE. I really like it. So in this case, let's just run this code. As you can see, the only line that is supposed to be running is this one. So if I just run with this one, because I said from math import square root, import from math import square root, automatically square root is available. So I can use it like that. But if I didn't do this one, and then that one was commented, now notice that if I run this one, it's gonna just say square root is not defined here. Then because I imported math, now I need to do say math dot square root. Now square root is defined. Notice Pycharm is very smart. It's automatically knows what other methods are available for that module math, and it's going to give you that one. So when you do from import math, that all the functions are there, then now you have to do math dot this. So if I just do not import math here, and then just do this one, import math as m. Now if I just run the code here, it's gonna complain, say that math math is not defined. So now I define it as math as alias m, so I could just use the shortcut m because that module is available for me. And then that would just also print 10. So I'm going to show you the differences, that what it works and what doesn't work, and how you fix it when it does the way that you do the import functions. So now let's just do these. I'm going to comment this line also, and then this time I'm going to have this math module here, and then from math I'm going to also do this one from math import the star. So let's just do these, and then this time I'm going to comment this line out, and then I'm going to uncomment this line for the POW. Earlier, I was telling you that the POW function has these kind of like, the POW is defined inside the math modules as well as a part of the standard library. So one of them is supporting only X and Y coordinate. One of them is X, Y, and then the remainder. So we have to check the difference, and I will show you the difference here by using this help on POW as well as math.pow. So when I just say from math, import math, and then from math import the star, those two is going to just allow me to use the math function. I could just take the star out and still do it, but notice that it got confused with one of them. The one that it says POW of 2, 10, 3, it says POW expected 2 argument, got 3 of them. It's why is that? Because of this import of these math modules. So the POW, when I'm doing this import, if I just take this line out and this line out, and just leave only the math module, because one of them is for math, and then the other one is from the standard in. Now notice that because math, and right here when we have math.pow, this one is giving you the syntax of math.pow. Let me just move this one a little bit up right there. And then right here, the first one that this POW function is 2 to the power of 10 is 1024, and that's accurate. This is just using the standard library of Python module. So Python has the standard library called POW that takes 2 and 10 as argument. The second one is just also using the Python POW function, which is 2, 10. 2 is X and 10 is Y and 3 is remainder. And as you can see here, the function, I just did a POW on help on this one. It has 3 arguments: base, exponential, and then mod, the remainder. So the remainder was 1 in this case because 2 to the power of 10, remainder 3 is always 1. So if I just change this remainder to 2, let's say, it's going to be 0 here. So let's just run that one to just show you the difference. Yeah. So right here, you can see the remainder is 0 this time. But in this function, math.pow is different. So math.pow, like this help right here, is for math with this function, which is inside the Python interpreter as the module POW, and the function POW is provided. And then here, I'm using the POW function inside the module math. And then inside the module math.pow, and the argument is this. And now you can see X to the power of Y. And then the slash is, and there's no value on, you cannot put a third value here. So if I just want to do that, something like here, say print, and then just get math.pow, and then notice the Pycharm is only helping me with giving me the values X coordination and Y coordination. There's no remainder on that case. So, let's do a 2 to the power of 5, which is 32. And then when you do that one, it automatically just works. And if I just run it, it is going to just show the same output, but 32 is here, output of that one. And then now if I just try to do print POW of 2 to the power of 2 to the power of 5. And notice that it gives me one more for the value of remainder. So the remainder, if I want to just do it with the remainder of, let's say, 1, so show me a difference for like 3, let's say, the remainder would be 1 always, because that's not divisible by even number. So you could just run that one, and this one, it does not have the math in front of it, so it uses the POW library there. And notice that the remainder is 2, because 2 to the power, to the power of 5, and then remainder becomes 3 in this case, which is 2 and then 3. And if this one was 2, the remainder was, let's say, the remainder would be 3, I believe. Let me just check. Oh, and this is 0. So to the power of 5, this is the module of it. The module of it is because to the power of 5 is 32, is even. And then for when it was 3, it was 2, and because 32. Let me see if I put 5, what is also even? No, it shouldn't be even. Yeah, it's 2. So 32, it is always the 2 that there. If I change this one to 1024, and let's say 10, because it's 1024, so 5, and then let's see, 4, the last. So the last number, the remainder, it's the remainder of the module. That is 1024. Up to 20 is even, and then the 4 is there. That's how we got that. And now I'm going to just comment out these lines, because none of these ones are actually going to be used when I do this last module demonstration. So let me resize this one here. And so I'm not gonna do the math module, and then so we're going to take this line out, and then the only line that I'm going to allow it here, I'm going to make this line below here. I'm gonna move this one and then import it here. And so we're going to use that one right here, and then clean up this one. And right here, these are all examples, so we're just going to comment these line up. We're not gonna use them either. So this is what I was telling earlier, saying that we could make that one and then move it there. I'm sure there's other shortcuts on Pycharm, and you can tell I'm not kind of a Pycharm person. I usually do on Vim, VI, editorial, or Emacs, or some kind of Unix, Linux environment. Pycharm, I use it, but I don't use it on that environment yet. Maybe I should use it. Visual Studio Code and other ones are also available. There's a lot of editorial. I like Vim, and I just do really easy work on that environment. So let's go back to this example. And at this time, I'm going to just move everything here. So you just have the last part of the code on the bottom, and then that way you could see the change just here. And then this part also uncommented, so we have it. And basically, this is what we have now in the top portion. I'm going to move this one a little bit bigger and go back to the line right here where the code starts. On line 27, and I say from random, import random int for num in a range of 6 and do this. So this is the Lotto example that I was showing you. So at this time, if I just want to generate 6 digits of between 1 and 64, this is a for statement that I'm saying first import random int functions from random module, and then when I load it, then I could use that function by saying for num in range of 6 times, and then print random int 1 and 64. Between 1 and 64 is going to just run this code and just find the numbers that are randomly generated. Every time you run it, you will get a set of 6-digit number right here. You can see that this is a fair example because the numbers are just changing every time you run it. Like if I just run it again, you see the number changes again. And then now this time is this set. And so you can just maybe play it for a long time and then see the options that whichever number you like the most. Like this one for number 4 come twice. And then you could also maybe just generate a like 1-digit what they call it is mega number. So you could do one more mega number between that one and just to print one more. So if you do five numbers and then the mega numbers there, so you could just change this one to 5 and then say print and then your mega number is, and then just print your mega numbers, and then right here you can just say print your 5 digits. I don't know if it's 5 or 6 digit, but 5-digit Lotto numbers are you're lucky. Let's make it lucky. I hope you all win the mega one. So here we just run it again. This time we just modified a little bit. So it's gonna give you the 5-digit and then the mega number also on the bottom after that. So let's see. Right here, you're lucky. 5-digit Lotto numbers, or it's gonna give you the 5 lucky numbers, and then your mega number is 52. So now I run it a second time. It is there. And then just to show you some of these random import modules, you could also get into the Python terminal and then just go and use it. Python terminal, when you just get into the terminal, you can just do same thing that you're doing inside Pycharm. You could type in here like excuse me. You could do a lot of stuff inside the Python terminals and get into Python or install pep, or you can go to the console here, Pycharm console. If you go to the Pycharm console, you're already inside the interpreter. So the Pycharm console, you can just say, for example, let's say import, what was it? We said from random import randint. So when you do randint, now dir of random, the random is not going to show because that one is not loaded yet. If I have to say import random, and then dir of random now shows. So if I need to get help, I could say print help on the random.randint, and then I could get it on any function. So randint is the function that we did, and you could just get help on it to say that it basically asks for two-digit left and right characters, A and B. So you could just put those two numbers and then do it. So if you want to use it, for example, you could just say print randint, because we said from random import randint, now we can just directly use it between 1 and 100, just generate numbers. So the numbers, you can just change the range here. You can start off with a bigger number or a smaller number, doesn't matter. You just run the same code every time you get a different number random. So when you want to say a dir of randint, there's a lot of functions inside here. This one also, you could do dir of randint, and I typed it wrong. Sorry, dir of randint. Yeah, dir of randint. You don't put a function name here. And then if you want to get help on it, again, you just do print on this one, and then instead of this, you just type in help. Right now it's frozen. Okay, so finally it's coming. I'm going to say print help and then randint. This one, you will just get the help on it here. So like my screen, if you could just say, well, let's just do the last time I showed you how to clear the screen, just using a print statement with a new line character. That was a tip on last time. And then this one may work on site Pycharm. Yeah, it does. So you could just clear it, and then now you say dir itself. You could see that the packages that are loaded, and since I loaded dir int at the end of this list, it's also showing random and random int, those two modules that I loaded. Initially, they are not there. Okay, so let's just go back to another example, which I have it on the command line here. I believe modules, this one. I could close this window. I don't need it. This is the window that I need. So that type, and I'm on the DOS prompt right now and running the command line. So this was the two script that I wanted to show you. The first one was import demo.py, which I just showed you with how to import and how to use it. So you can also get inside the command line to just do the same thing from the command line. But before I use it on Pycharm, let me just show you on the command line. So if I just do like a Python import and demo.py, this one is just basically going to do the exact thing that we did the last thing. Your lucky 5-digit lottery numbers, or if I clear my screen and then just run this command, every time I run that command, it's gonna give me a list of set of different numbers. You see that? So now let's do the second program, which is this one, more plot sine and cosine.py. In this program, as you can see, I wrote it a long time ago, but I have been demonstrating it at the Pasadena City College when I was teaching Python program, as well as, and now I'm going to demo this one on YouTube. So you can see the way this program works is basically I'm using the matplotlib, and then from matplotlib import pyplot, and the pyplot is just loaded as a plot. So then I could say plot.show and then use the show function. Whatever plot methods are available, I could use those ones. Similarly, I do import numpy as NP. Numpy is the scientific kind of a module that it does numerical analysis and a lot of kind of good for data science and kind of scientific programming. So you're welcome to just use it. And someday I'm going to do a video on NumPy as well. And then at this time, we're going to just use it, and we're going to just show you some of the functionality of these two modules and just to go over it. So here I just define the X and Y coordinate and then the plot the X and Y coordinate and the X level, Y level, legends, title, and then show it. So it's very easy program to do it for X cosine I did. And then you have to kind of write it in the scope of blocks of code, which we call it functions. Each function does similar activity of something like one plots the cosine function, another one the cosine function, another one, both of them. So I break it into three different subcategories or sub-block of tasks to do it. Whenever you do top-down programming, you're breaking a larger program into smaller tasks and the smaller task into subtask, and then you write the algorithm to handle the subtask, and then when you're done with the subtask, you go to the next one. All of a sudden you complete a big module that a big application that is modularized together. It's much easier to maintain it. It's much easier to recode it or reverse engineer it or update it or whatever you want to do with it. It's much easier when modularization is in place. And a lot of great operating system like Unix, Linux, Windows, a lot of databases, Oracle, MySQL, C++ programming, C, Python, C, Python, everything is all in allowing you to do those kind of tricks and techniques and are already done themselves. So let's go to the demonstration of this one. In order to run this one, I could do Python, because on the first line, if you just say use Python 3, as you can see on the first line of this plot, sine cosine.py, normally you have like a shebang and then the Python interpreter, which you can get it from sys.executable value. You can put it here, or if your environment knows Python 3 is your environment, you can put that one. And then if you're on a Linux or Unix environment, you could do something like shebang user ben env Python. But again, these matplot and numpy has to be already installed on your modules, as well as make sure that if you are running it on that platform, whether it's Mac or Linux, you have some supported GUI, which is Linux is GNOME, and then X is for Xcode is for Mac already anyway. So you can use those two. And then the graph will be just plotted. So now let's just plot it. So my Python 3 interpreter is here is Python 3. And now if I just say Python 3 followed by the plot sine cosine.py, I'm just saying that use Python 3 interpreter, and instead of going to the interactive, I'm just giving a file .py extension as argument, and then I say just open that one. So now it's going to just plot that one. In order to do the rendering, everything, it takes a couple of seconds, depending on the speed of processor and memory. But now you can see that that program is loading, and the sine function here, the graph of sine is there. And notice the x-axis, the y-axis, the values, and then the 4pi, all that information. I put it in there in order to just make sure that the calculation is done correctly for the sine there. And then as you can see, it starts from 0 here and then isolates here. And then if I close this one, then the cosine comes in. Similarly, I'm going to move it here. So the cosine function is also there, and then now notice cosine, it starts from 1 here, and then it goes down there, the opposite of what sine was doing. So if I do both of them here, now you can see the blue is the sine, and then the orange is the cosine. So they do the same kind of isolation over, but notice the pattern. So it doesn't matter how long they do it, it's always the same thing. It's really nice kind of graphic demonstration of sine and cosine there. I hope you enjoyed it. I'm going to just do one more thing here, and then let me close this one, and I'm going to just go in Pycharm here again, and this time I'm going to say open. I'm gonna just open from YouTube this directory, the plot menu, this one, and then I'm gonna close this other one. So this one, now if I just run this one, I need to say run from run it, and then I have to select the new one. So the new one is plot sine and cosine here. And so this one, it just says that I don't have the matplotlib. In order for that one to be done, if you just don't have it on this environment, the virtual environment that this one is running, then you need to install it. So in order to do that, when you go to Pycharm here, Python packages, and then under Python packages, you say the name of the matplotlib. So the name of the module that we need is matplotlib here. And when I click on it, it just says it's not installed. Do you want to install it? You see here, it just says install. So I'm going to click on install, and that will install it on this environment. So the Python IDE is a fully integrated development environment. It allows you to do it. Right now, it was asking me, do you want to give it sudo access or admin access? And I said, yes, go ahead, do it. And once it is done, then I can also get into the console here. On the console, I could say import matplotlib. If that one is installed, it's not going to complain. But since it is still trying to install it now, it is not available yet. This is read-only view, so that's okay. And notice that my IDE environment is different from my command line. Here, if I just say Python 3 and then say import matplotlib, it's not gonna be just complaining that this library is not there. So now there of matplotlib, it is available. So I need the same thing from the matplotlib to just make sure that one is available. So on this packages, when I went there, it is a little bit too slow. While this one is just doing it, I'm going to show you something more on the command line. So let me quit out of here, and notice this is screen, clear screen. I don't have any directory called _pycache here. And double underscore pycache, and then double underscore. So when you're loading a module inside Python, then you can just say import the name of the module. You don't have to say the extension, because this is a user-defined module, not a system or a part of a library that are coming like numpy. So here, when we do the extension of loading it, you're doing it similarly to like import numpy, import math. You're just not giving the extension. So let's just do Python 3 here, and I'm going to import both of these modules. Say import import demo is one, and then it runs it. When you import it, it runs the code here for you, and it does execute it. So now there of these lists, in addition to other ones, the import modules also in the list. But if I just do import and then there of import demo, is all the things that are available for that one, it will just list it for me, like random int is there, num is there. So I could just say, for example, print and let's say import demo dot num. So see what was the value of num. The last time was num was 4, and then random int. And now I have to just give some value between 1 and 10, let's say. Whatever value I gave, then I get a value for it. Like 1,000, then it's just going to give a different number. So as many times you run, you get different random number generator. But notice that this syntax and then this dir, now it shows only that. So if I just want to import the other module, which is plot, sine, and cosine, now this module is also loaded. Notice that that module is loading because it's running it. It's gonna open some sine and cosine here. And you can see that the graph now opens up here. So I'm inside here running it. And now I'm gonna close the sine function. It comes out the cosine here. And then I go, okay, that's great. Let me see the sine and cosine. That's also great. So everything looked good. And then I'm just going to say, okay, that's done. Now this one, now notice that plot sine and cosine also shows in the dir list. Now I do a dir of plot sine and cosine. All the modules are there. For example, if I want to see the x value, y value, or something, I could say print plot sine cosine dot x and then that would print me in the x value. Similarly, if I want to see the y values, I can get it. Similarly, the z values, I get it. So a lot of the dir, plot, sine, and cosine are there. But if you're just doing the details of it, what are like plot or numpy, look at the dir of plot, sine, cosine dot numpy. This is the same list of the thing. So if I do a type on this one, this is saying class module. Now if I say import numpy, and then just without as num and p, because I did it on the other one, numpy, I could just say dir of numpy, and I get the same list that I got above over there. For this list is the same list as this list. And then if as the list of dir this. So if I just do type of and numpy is also showing you that it's a class modules, as well as type of this one is class module. And then we could get a lot more details on each one of them, but at this time I'm going to exit out of this one to show you what I wanted to show you. Another thing that I got into the command line running those ones, I told you that this PyCache directory was not there, but as a result of that import, it created these PyCache directories. So now I'm gonna go cd to the PyCache. So every time you load it, this directory gets created, the files are getting updated here. So now notice that for each of the module name .cpython version 3.10, CPyC is the Python compile code or bytecode. So that is what that one is, which is runs faster. So now if I just have the Python interpreter 3, and then I just gave this as input, I could just get the same output that last time I got it from the command line. Similarly, if I just run this one with this plot menu, it will do the graph of sine and cosine as we saw it, and then that's much faster compared to the one that was there. But because it's in the cache, it's loading it, and notice that it came out, and you're using the bytecode executable now. This is it. So we demonstrated that as well. And then the Pycharm, and this is for the time that we use the import functions to do demonstration. So let's see if this one is doing the package already installed or not. It is still shows as installed. Let's see if it is showing it is installed or not. Here it prompts me, say, elevate it, and say, yes, go ahead, it elevated. But let's see if it does the installation. If it doesn't do it, I already showed you from this interface and the virtual environment that may take a while to just load the modules inside Pycharm. And we can just give it a few minutes, and then just let me pause the video for a second. As you can see, it was saying that updating is updating the repository. Let me just try to run it, see if this time it finds it or not. If it finds it, then it's going to load it properly. Looks like it's doing it. It's index complete, 5 minutes, 3 seconds. Shared indexes. So it had to do the indices of 848 of 5,954 packages, but it's taking a little bit to just load it. So let's see if it does show up quickly. We're all about timing. Right now it's saying indexing, and it's like the progress is not even halfway updating. It's making faster now as I'm complaining about the speed. So it did work successfully. So inside Pycharm was able to identify the package that was missing. I said, go ahead, install it. It asked me for the privilege mode, and then I allow it. And now as a result, and that program is running inside the Pycharm as well, because the IDE also have the same thing that I had on the command line, same kind of modules available. So the third one is showing up, and then the third one we see the both sine and cosine here. And with that, let's just call it for the day. I hope you enjoyed it, and please don't forget to subscribe and like our videos so I could make more productive videos for your needs. I need to just support you, and I'm using my weekends and holidays to just make these videos for people that they cannot go to universities and colleges because they're so expensive, or whatever other reasons. You could just go online and learn it online by just accessing to the internet and YouTube channel. That's all you need. So in order for you to just do it, please subscribe to my channel, and you will see a lot of these videos on Python, C# programming, Bash programming, awkward programming, grep, set, awk, Vim, MySQL database, C programming, C++ programming, Unix, everything I have over there. And you just need to just watch them. Enjoy it. Have a great one. Take care. Love and peace to all.